Here's an application problem. The type is called max-min, and these are very closely tied to quadratic functions. If you think about a maximum, it's usually a peak, or a minimum, it's usually the low point of the valley. And it is possible to have multiple maxima or multiple minima, but for our purposes, we're going to restrict ourselves to quadratic functions. So let's take a look at this problem. A pig pen is built against a barn with fencing on the other three sides. So we're making the assumption that the barn has an unlimited length for our purposes, and that we have 80 feet of fencing available to form the other three sides. We're then asked what dimensions produce the maximum area, and we're given a hint. Let x equal the width of the pen. One quantity which is not asked for, but which I can find easily, is the length of this third side here. Because the total length is 80 feet, and we have used x feet for each of the sides of the width, we can then designate the third side as being 80 minus 2x. Next, what I want to do is create a function which is based on the quantity that I'm asked to maximize. And so I'm asked to find the maximum area. And in order to maximize a function, I first have to create that function. So I need to create this function for area. And we can just use the formula. Area of a rectangular pen is going to be length times the width. But based on the quantities that we have, the length we know is 80 minus 2x, and the width is just x. So we can multiply this out, and I'm going to put these in descending order. Negative 2x times x gives me negative 2x squared, and then the other term is a positive 80x. And when I write out this function, I can call it a, but this function is dependent on the variable x, so I'll designate it as a of x, and that is my area function. Next, I'm going to go back to the idea of finding the maximum area. And whenever we look for the maximum, that's the high point. And in relation to our quadratic function, which is a parabola, this is a face-down parabola because it's got a negative coefficient in front of the x squared. And for this face-down parabola, that high point is going to be the vertex. So whenever we see maximum or minimum, we generally will jump to the idea of it being the vertex. And I think the easiest way to find the vertex for this function is to use our vertex formula. And the x-coordinate is given to be negative b divided by 2a, where a and b are the coefficients of the squared and the first power term. So from the formula, we have a negative sign. B is equal to a positive 80 divided by 2 times a, which is equal to negative 2. So we end up with the negatives canceling, and 80 divided by 4 gives us 20. And now let's interpret the answer in the context of the problem. X is equal to 20, and we are seeing that our units are in feet, and so that is the width. And next we can take a look at the length, which is going to be 80 minus 2x, so that's 2 times our 20 feet, which will give us 80 minus 40 is equal to 40 feet. And that's equal to our length. So that answers the question. What dimensions produce the maximum area would be a width of 20 feet by a length of 40 feet. And one question that we're not asked here, but we could find out if we wanted, would be to find the actual maximum area. So let's go ahead and do that. We're going to get the maximum area when x is equal to 20, so we'll plug that in and just say a of 20, or the area when x is equal to 20 is equal to, going back to our quadratic equation, we get negative 2 times x squared, so that's 20, squared, plus 80x. So that's 80 times 20. And here we get 20 squared is 400, So 2 times that gives us a negative 800. And then 80 times 20 is 1600. It's positive. And so the final answer is a positive 800. And the units for area are going to be in square feet or feet squared. But let's make it square feet. And if we use these dimensions of 20 feet by 40 feet, we can see then that we will produce that area of 800 square feet.